Hi there, in this video we're going to talk about arithmetic sequences. So I'm going to start off by giving you two sequences and finding the nth term. And remember, finding the nth term means finding a formula for the sequence. And so here, the first thing you want to look at is there a common difference? So we just want to see, and that is actually an arithmetic sequence if there is a common difference, but we'll get to the formal definition. So I'm looking at this and I see 2, 7, 12, 17. And so what does it take to go from 2 to 7? And then 7 to 12, and then 12 to 17. So notice that every time we are adding 5. So if you add 5, so that's the common difference. So if you look at, when I say common difference, you look at the 7 minus 2, that's 5. And then if you do 12 minus 7, so the next term minus the previous term, that's 5. 17 minus 12, that's 5. So there's a common difference of 5. And so when I look at this, as we talked about before in the previous section, I can look at this as, okay, 5n, because the common difference is 5, so it's going to be 5n. But when n is 1, I start at 2, right? So a sub 1 is 2. So when n is 1, that's 5 times 1. What do I need to do? What do I need to add or subtract to get a 2? And it looks like if I did 5 minus 3 is 2. So I'm guessing that my a sub n will be 5n minus 3. So when n is 1, we're going to get 2. But always check it with something else. So 1, 2, 3, 4. So a sub 4 is 17. So that means that when n is 4, I should get 17. So my a sub n is 5n minus 3. So a sub 4 will be 5 times 4, which is 20, minus 3. So that does give us 17. So it looks like my formula is correct. So then I can say a sub n with confidence is 5n minus 3. And so that will be the nth term of the sequence. And so now I can use this to find any term. If I want to find a sub 20, plug in 20 for n. If I wanted to find the 1000th term, put in n equals 1000, and so on. So what about the second one? So here we go from 8 is our A1, to 11, then to 14, then to 17. So you may have already spotted that. What are we doing to get from 8 to all the other terms? So it looks like we're adding 3. So what will the next term be? Add 3, we would get 20, right? So that will be so 1, 2, 3, 4, 5. So a sub 5 looks like it would be 20. So my a sub n then is going to be 3n plus or minus something. And I know my a sub 1 is 8. So when n is 1, so 3 times 1 is 3, what do I need to add or subtract to get 8? In this case, we need to add 5, right? So it's looking like my a sub n is going to be 3n plus 5. So my a sub 1 then is 3 times 1 plus 5, which is 8. So that works. And pick another one. Pick one that you were given. So let's look at 17 again. So that's 1, 2, 3. That's when n is 4. So a sub 4 is then 3 times 4 plus 5. Do we get 17? 3 times 4 is 12 plus 5. That is in fact 17. So it looks like my a sub n equal to 3n plus 5 works. So that is the formula. So these two are examples of arithmetic sequences. And so you might be thinking, well, why are you putting the common difference? That's the 5n, and then the common difference here is 3, so why are you doing 3n? So let's explore that a little bit more. So back to part A. So notice that one of the things we noticed was that the common difference was 5. So we call that D, the common difference. And so looking at the first term, a sub 1 is 2. Now, when you have a common difference, that means that the next term, you're going to get it by adding that common difference. So it's going to be 2 plus 5. How am I going to get the next term? Well, I'm going to add 5 to the previous term. but keeping it with A1, so we're going to focus on A1, this is going to be 2, right, plus, to get to A3, how many times have I added 5? Right, there's the first time, I'm adding it twice, so it's going to be 2 times 5. Right, by this time I'm adding it to the first term, I've added the common difference twice. So what about A4? How many times will I have add 5? So I add it once, I add it twice, I'm going to add it 3 times. So it's going to be 2 plus 3 times the common difference, and so on. Right, so then that means for A5, how many times will I have added the common difference of 5? So 1, 2, 3. So to get A5, I'm going to add it 4 times. And so this starts giving me the terms. And so what can I do for A sub n then? A sub n then will be A1, 2, plus, how many times will I have added the common difference here? Right, the common difference is 5, so it's going to be 5 times what? And so notice a pattern here. For a sub 5, I added it 4 times. For a sub 4, I added it 3 times. A sub 3, 2 times. A sub 2, 1 time. So for a sub n, so it looks like we're adding it 1 less. So it's going to be n minus 1 times 5. And so when you multiply this out, right, I get 2 plus, distribute the 5n minus 5. Combine my terms, I get 5n, 2 minus 5 is minus 3. So it's just that then a quicker way of doing it is noticing that the common difference is the coefficient of your n. And so in general, we can devise the formula. So let me go back to part B. So will I get the same thing? So notice we know A1 is 8, and the common difference here is 3. So will we get the same thing? So it will be, if we do the same thing here, A1 is 8, A2 is 8 plus 3, A3 will be 8 plus, now I'm going to add it twice, so 3 plus 3 is 6, but I'm just going to say 2 times 3, and then A4, and so on, right? A plus, now I'm going to add the common difference 3 times, and so on. So A sub n will be 8 plus n minus 1 times the common difference of 3. Simplify this, 8 plus distributed 3, 3n minus 3. Combine like terms, so I'm going to get A sub n is 3n, 8 minus 3 is 5, which is what we had gotten up here. So that's how we can get the formula for A sub n. So in general, the definition of our arithmetic sequence is that when you have the first term, so this A is your A sub 1, and then you just add the common difference forever. So you go A plus D, A plus 2D, 3D, and so on. So A is the first term, so the first term we call it A sub 1, and D is the common difference. And so we get this formula. A sub n is equal to A plus n minus 1 D. So this will be something good to remember as long as you have an arithmetic sequence. In the next section, we're going to study geometric sequences, so the formulas will be different. So arithmetic is you have a common difference, you're adding or subtracting something each time. So let's look at this example. Find a formula for A sub n, and if we do it using this formula, I'm going to have, this is my A sub 1. Right? A sub 1 is 100. And so we need to find D. So what's D? To find D, do the next term minus the first term. So I'm going to do D is 68 minus 100, which is negative 32. And then just make sure that that works. What if you do 36 minus 68? 36 minus 68 still gives you negative 32. And if you do 4 minus 36, you're still going to get negative 32. So just kind of make sure that the difference is the same throughout. So D is negative 32. And so now I can say my A sub n is then A1, so 100 plus n minus 1 times D, and D is negative 32. And you can distribute, so I'm going to get 100 plus, well, it's really, when you multiply the minus 32, and it's really going to be minus 32, and minus a minus is plus 32. Combine like terms, so our A sub n is negative 32n plus 132. You could have also done it the short way, which is what I did in the first two examples, where we say, okay, what's the difference? The difference is a negative 32, so is negative 32n. What do you do to get 100 when n is 1? You need to add or subtract something. So because I have negative 32 when n is 1, I will have to add 132 to get positive 100. And so you can do it that way as well. So now you have two ways. But the formula is helpful for other types of examples. So let's go to our next example. Example 2. Find A sub n, the nth term of an arithmetic sequence with A sub 1 is 25 and D is equal to 14. So, well, I think I'm thinking of my third example is a little bit harder. So I know A sub n is A1 plus n minus 1 times the common difference. So that's the formula. So in this case, I'm given A sub 1 is 25, so it's going to be 25 plus n minus 1 times D, and D is 14. And simplify this, so it's going to be 25 plus 14 and minus 14. And then just combine like terms. And so what do we get? This is going to be 14n plus 11. So that will be your A sub n. So when you're given the first term and the difference, it's not as bad. So let's try the third example. This one is a little bit more involved. Find the 1000th term of an arithmetic sequence if the 11th term is 52 and the 19th term is 92. So I don't have the first term, and I don't have the common difference either, so I can't try to figure out what these are, but that's where the formula comes in handy. So I know A sub n is A1 plus n minus 1 times the common difference. So we don't have A1, we don't have D, but we do have some n's. We have n11 and n19. So we can at least figure that out. So when n is 11, we're going to have A11 is equal to A1 plus 11 minus 1. 11 minus 1 is 10D. Right? And I know A11 is 52, so we can plug that in. So I can say 52 is equal to A1 plus 10D. Now, when n is 19, what do we get? So I'm going to have A19 equals A1 plus 19 minus 1. So 19 minus 1 is 18. So I get 18D. And same thing as we did up here, we know A19 is given to be 92. So we're going to have 92 equals A1 plus 18D. And notice now we have a system of equations with two variables and two equations. So solve the system. So what I'm gonna do, because the 92 is larger and the 18 is larger, I'm gonna multiply this equation by a -1. So multiply by a -1 on both sides. So what I'm gonna get when I multiply by -1 is gonna be minus 52 equals negative A1 minus 10 And my second equation is going to stay the same. So 92 equals A1 plus 18D. So I'm using the elimination method. So those will cancel. We eliminated A1. So 40 equals 8D. And notice that this tells us then divide both sides by 8. So I'm going to have D is equal to 5. So we have our common difference. So now all we need to do is find A1. And we can go to any of these two up here. So I'm going to go to the first one. So we know from equation 1 that 52 equals A1 plus 10D. We just found D to be 5. So 52 equals A1 plus 10 times 5, the common difference. So can we get A1? 52 equals A1 plus 50. Yep, subtract 50 from both sides. So 2 is equal to A1. Perfect. So now we have A1, that's my therefore. A1 is 2, and the common difference is 5. So our nth term is, right, A1 plus n minus 1D. That's the formula. So now we know A1. So 2 plus n minus 1 times 5. Now keep in mind, what were we trying to find? The question said to find the 1000 term. So when n is 1000. So it wasn't asking us to find the nth term, even though we did. But we need that to be able to find the 1000 term. So let n equal 1000. So you're going to have A1000, the 1000 term is 2 plus 1000 minus 1, so 999 times 5, which gives us 2 plus, when you do 999 times 5, you get 4,995, so that will be 4,997 will be the 1000 term. And we'll be done. So that's one way where the formula really comes in handy. All right, so let's go to another example. And this one is going to be a little bit, perhaps maybe, more intimidating because it looks like it has fractions. Well, it does have fractions. So, but just as I mentioned in the previous video for the previous section, don't let a fraction intimidate you. So take the numerator as a sequence and the denominator as another sequence. So one of the things doing that is I'm going to look at the difference in the numerator. So it looks like I'm adding 2 to get to that one. And then, this one, it doesn't go up by 2. But then notice that between 9 and 11, it goes up by 2 again. So what's going on the bottom? The bottom is to get from 5 to 13, we add 8. And then that term is also not quite matching. But then notice that from here, to get from 29 to 37, we're adding 8. So it looks like the difference might be 2, but this term is throwing us off. Which, that makes me think, I wonder if it has been reduced. So, if it has been reduced, and if the common difference is in fact 2, what would we get if we continued by 2? So if I added 2, what would that be? So let's rewrite it. So it'll be 3/5, 5/13, and then if I go add 2, if I add 2 to 5, what would I get? It would be 7, right? And then add 2 to 7, I will get 9. And then add 2 to 9, I get 11. So that seems to be working. So does that also happen on the bottom? So let's see, if I add 8, 5 plus 8 is 13. So if I add 8 to 13, what do we get? 13 plus 8 is 21. So it looks like that might be 21. And notice if you reduce this one, 7 over 21 is in fact 1/3. But so that is the actual term. And so now our difference is matching up. So it's 2, 2, 2, 2. So this will be So when I'm finding my a sub n, I'm going to have a sequence in the numerator. So a sub 1 is 3, so it'll be 3 plus n minus 1 times the common difference, which is 2. What's going on the bottom? On the bottom, we're adding 8. We're adding 8, adding 8. So that means that the common difference here is 8. So a1 is 5, so I'm going to have 5 plus n minus 1 times 8. And then you simplify it. So this will be 3 plus 2n minus 2, which reduces to what? 2n plus 1. Over, same thing on the bottom here. 5 plus, distribute the 8. So 8n minus 8. Combine like terms, so this will be 8n. 5 minus 8 is negative 3. And so my a sub n is 2n plus 1 for the numerator and 8n minus 3 for the denominator. And that is our sequence. You could have also used my shortcut of the common difference is 2 here. So you will say the numerator will be 2n plus or minus something. When n is 1, you get 2. What do you need to add or subtract to get 3? We add 1. Common difference here is 8. So it'll be 8n. And then to get 5 when n is 1, what do you need to add or subtract? 8 times 1 is 8. To get 5, we need to subtract 3. And so we get the same thing. All right. Hopefully that helps you get through this section. I am going to record another video for the sequence of partial sums for arithmetic sequences.